Today, I will discuss to you how to find the epicenter of an earthquake. Our objective is to find the epicenter of an earthquake given the time difference of the arrival of P wave and S wave from 3 recording stations. Things you need for this activity. You need a drawing compass, a ruler, pencil, calculator. We will also be needing a map. We will use the Philippine map for this activity. Also, we need a data table containing the time difference in the arrival of P wave and S wave. So there are 3 recording stations. You need at least 3 recording stations in order for us to find the epicenter of this particular earthquake. So we have a recording station in Batangas, Puerto Princesa, and Davao. And these are the time difference of the arrival of P and S wave as recorded from each of the recording stations. So the first step is to fill out the data needed in this table. In order to fill out the data in the third column, we need a formula. So the formula for calculating the distance of the epicenter from the recording station is here. Okay, so D is equal to TD divided by 8 seconds times 100 kilometers, where D is the distance in kilometers from the epicenter. Okay, so the distance of the recording station to the epicenter is represented by the variable D here. Okay, and that distance is expressed in kilometers. And then TD is the time difference in the arrival of P and S waves. So TD is in seconds. So this formula is specially suited because 8 seconds is the interval between the times of arrival of P wave and S wave at a distance of 100 kilometers. So let us use this formula in order to determine the distance of the epicenter from each of the recording stations. So Batangas is 44.8 seconds. So let's use the formula. So you have here you have D is equal to 44.8 seconds. Let's check again. That's 44.8 seconds divided by 8 seconds times 100 kilometers. So seconds here. Okay, you can divide out second. Okay, so the unit for your answer will be in kilometers. Okay, so let's use this calculator. You have 44.8 seconds divided by 8 seconds equals times 100 kilometers. So you have 560 kilometers. So this is for Batangas recording station. So let's write that here in the table. So you have 560 kilometers. So the epicenter is 560 kilometers from the recording station, which is located in Batangas. And then let us repeat the same procedure for Puerto Princesa and Davao. So for Puerto Princesa, we have D is equal to 24.64 seconds divided by 8 seconds times 100 kilometers. So you have here 24.64 divided by 8 seconds times 100 kilometers. So you have 308 kilometers for Puerto Princesa. Okay, so that's 308 kilometers. And then for Davao, 38.4. So this is for Davao. So you have D is equal to 38.4 seconds over 8 seconds times 100 kilometers. So you have 38.4 divided by 8 seconds times 100 kilometers. So you have 480 kilometers. The distance of the epicenter of this earthquake is 480 kilometers relative to the recording station in Davao. So, in order to proceed, we need to determine the scale of our map. Okay, so this is our map. This is a Philippine map. Okay, and the scale of this map is indicated here. So, right here. So, you see that you have 0, 0, 50, 100, 150 kilometers. So, in order for us to determine the scale of this map, we need a ruler. Okay, so let's measure this distance here from 0. Okay, that distance from 0 up to, say for example, 50. Okay, so this means that this particular distance from 0 to 50, okay, so this distance here represents 50 kilometers in the real terrain. Okay, so let's try to measure that. So we will be using millimeters. Okay, so be sure that the 0 is pointing at 0. Okay, so this here, the 0 in the ruler must be pointing here at the 0 in the map. Okay, and then let's count how many millimeters is this particular distance in the map. Okay, so that is about 7 millimeters. Okay, so this map, for every 7 millimeters, you have 50 kilometers. So the scale of our map is 7. So that is 7 millimeters per 50 kilometers. So you have for every 50 kilometers, you have 7 millimeters in the map. So that means that in the real terrain, 50 kilometers is represented by a distance of 7 millimeters in the map. So this is just the same for all the recording stations. So that's 50 kilometers per 7 millimeters in the map. So we are now in the 5th column of this table. We will try to fill out the data for the 5th column. So in order to do that, we will use the map scale to convert these distances, 560, 308, and 480 kilometers into millimeters. So we will convert them to millimeters so that we can represent these distances in the map. Okay, so how do we convert 560 kilometers to millimeter? So that's simple. Okay, so we will just use the map scale in order to do that. So 560 divided by 50 kilometers times 7 millimeters. Okay, so let's get our calculator. So let's convert them. So 560 divided by 50 equals times 7. Okay, so 560 kilometers is 78.4 millimeters in the map. Okay, so that is 78.4 millimeters in the map. Okay, so let us repeat the same procedure for Puerto Princesa and Davao. So you have 308 divided by 50 equals times 7. So you have 43.12 millimeters. So 308 kilometers is represented by 43.12 millimeters in the map. Okay, so for Davao, you have 480 divided by 50 times 7. So you have 67.2 millimeters. Okay, so this time let us use this data in order to look for the epicenter. Okay, so we need particularly these measurements here in the fifth column of our table. So here is our map. So first, let us mark the recording stations. Okay, so first is let's look for Batangas recording station. So Batangas is right here. Okay, so that's Batangas. So that corresponds, this point here corresponds to this point. Okay, so this is Batangas. So let us mark this point here. Okay, so that's Batangas recording station, and we have here the Puerto Princesa recording station. So let's mark that. Okay, so that's our recording station in Puerto Princesa. Okay, and then here we will also mark the recording station in Davao. So that's the recording station in Davao. So we have 3 recording stations in total. So again, we need at least 3 recording stations in order to locate the epicenter of an earthquake. Now, next step, we need to measure, for Batangas, we need to measure 78.4 millimeters. You can have it in any direction. Okay, so be sure that the 0 in the ruler is pointing at Batangas. Okay, so that's 0 there, and then 78.4 is about right here. So that's 75, 76, 77, 78. So let's have this point here. Okay, so that's 78.4. Okay, so for Puerto Princesa, we have 43.12. So 43.12 millimeter. So this is 40, 41, 42, 43.12. About right here. Okay? And then for Davao, we have 67. So 67. You can also do it like this if you want. So 0 points at Davao, and then 67.2. So you have here 65, 66, 67.2. So about right here. Okay, so the next step is to draw the circles. Okay, so the distances, these distances here, okay, these 3 are actually radius of a circle. Okay? So, let's make the circle using our compass. So, let's put this here in Batangas, and then the pencil should be here in this point that we just made earlier. Okay? So, make a circle with a radius of 78.4 millimeter. Okay, that is for Batangas recording station. Okay, so let's make the circles. Okay, so these are now the circles that we've made. Okay, so the biggest circle belongs to Batangas recording station. So this is that circle, and then for Puerto Princesa we have this. Okay, and then for Davao we have this circle here. So the point at which these circles intersect or nearly intersect, so in this case they intersect at this point. Okay, let's use this pen to mark that spot. Okay, so where the three circles intersect, that is where the earthquake epicenter is.